So for today, we're going to look at that alternative type of market structure that we set up last week, and that is looking at a type of market structure where the oligopolists compete against each other, but rather than setting output levels, as they did when we looked at Cornell and Stackelberg, the choice variable, the strategy that these firms choose over, is price. Now, intuitively, it's nice to look at the Bertrand model. It's nice to look at the situation where firms choose price as their strategy. Because if you think about it, if firms were choosing upon the output level that they produce, it can take an awful long time to change output levels, to increase or decrease inventories. Whereas price, though, is something that can be changed very, very quickly. Now, if you look at the Bertrand model, this was initially set up back in the 1830s, where again, okay, price would just be a labelling aspect. If you think about the way in which firms would set their prices in a modern economy, it's even more simple than that. You don't even have to change a label. It's pressing a button on a system. So in that sense, it's a much more appealing way of thinking about a market structure and what firms actually do and how they compete against each other. So that's what we're going to do for today. We're going to look at a type of market structure where there are a limited number of firms who compete against each other. And the way in which they compete against each other is in terms of the price that they set. That's the strategy. That is what they choose over. And all the game theoretic principles that we've been through before underpin all this. What will the firms want to do? They'll want to choose a strategy, in this case set a price, such that they maximise their profits, such that they get the best possible outcome for them. Now, this type of market structure, where firms compete against each other, and you might have touched upon this in other modules that you've done over the course of your 3 years here, it's known as the Bertrand model, where firms compete against each other on price. And in contrast to what we did with Cornell and Stackelberg last time, price is an appealing thing to look at, because realistically, that is a more intuitive and natural way within which firms will compete against each other. Cornell, Stackelberg are nice. We get some nice findings. We can draw in the game theoretic implications of them. But Bertrand in itself is more intuitively appealing, how firms actually behave in the real world. So that's what we're going to do. That's a general overview of the Bertrand model and what is going to happen and what we're going to be looking at. What I want to do, though, just before we do the formal part of going through the model, is give you an idea then about the basic setup. I can see some of you are still busily writing. I do apologise, I'm going to skip onto the next slide. Now, but don't forget, all of these are on Blackboard for you. So, the basic setup. And it's going to be very, very similar to what we did with Cornell last week. We're going to look at a simultaneous move game. So it's a static game where these firms are choosing their strategy at the same time. It just happens to be that this strategy is in terms of price rather than in terms of quantity. But, again, to make things nice and simple, not to complicate things, we'll look at firms who are producing an homogeneous product. There is no brand differentiation. There's no aspect of brand loyalty. It's exactly the same good that these firms are producing. And the marginal cost of producing this good is exactly the same between the firms. If you think about it, they're competing against each other, but they're not competing in terms of any cost considerations. They're not competing in terms of any aspect of product detail. The only thing these firms can compete on is the price that they charge. It's the only thing they compete on. And that's the one aspect that firms have absolute control over. And what about when they produce this output? They're producing for a certain price. The customers will always buy, naturally, from the cheapest seller. So, if firms charge a price that's less than the rivals, the customers will purchase the good from that firm. But if both sellers charge exactly, I say both sellers, we're going to look at a duopoly situation. So an oligopoly, but we'll restrict it down to just two competing firms. So if both sellers charge exactly the same price, who do customers buy from? Well, we assume that exactly half of the customers buy it from one firm and exactly half of the customers buy it from the other firm. So they're producing the same good, the same price. What do customers do? Well, they randomly choose one of the two firms. So essentially, that's what we've got. They charge the same price. Half the customers go to one firm, half of the customers will go to the other. So that's the basic idea. Now this, though, this next part is important. What do the firms want to do? They want to maximise their profits. They want to get the best possible outcome for them, for themselves. So, charging the same price, same cost considerations, same good. How are they going to maximise their profits? By getting as many customers to buy their good as possible. So what, intuitively, does that mean? Well, if you want the customers to come to you, to buy the product from you, you've got to charge a lower price than your rival. So whatever price your rival will charge, each firm will want to just marginally undercut it, charge a lower price. If you do that, given the way that we set this up, what will the customers do? They'll come to you and purchase the good from you, because it's cheaper. But firms, though, will only wish to do this as long as the price that can be charged is not less than the marginal cost of production. Because it's pointless producing a good, selling it to customers, if you're making a loss. So any firm would not want to charge a price less than the marginal cost of production. You would rather not sell at all and make zero profits, as opposed to sell each unit at a loss. Because remember, what we're looking at here is not just a static game, but it's a single-shot game. You can't make losses in the present with the expectation of making higher profits in the future. We're just looking at a single-shot game. So, no firm will want to charge a price that's less than the marginal cost of production. So, in its entirety, that's what we're looking at. That is our basic setup. So, with that in mind, you can have this in front of you in both handouts, plus it's in the lecture notes anyway. But what I want to do is go through this in a slightly different way than when we did Cornell and Stackelberg. We looked at Cornell and Stackelberg. We used a bit of algebra, not a huge amount, but a little bit of algebra to describe what was going on. And we identified the idea of a best response function. And we did it algebraically. Well, what I now want to do for Bertrand is the same sort of idea. We're going to identify for the firms their best response functions. But we're going to do it graphically. So, this is the basic setup. That's what we're looking at. Now think about, cast your mind back to what we did in lectures when we looked at mixed strategies. And we looked at the best response functions. And we drew the best response functions. Well, we were looking at two players competing against each other. And what one player would choose to do was dependent upon the strategy chosen by the other player. Now, in terms of mixed strategies, that was all in terms of the probability that these firms charged. Did you want to know how note?
That's all.
Okay. What these firms did is they chose their optimal strategy given the mixed strategy chosen by the other firm. For mixed strategies, that's all in terms of probabilities. So, for example, we might have had the man and the woman on the axes, and the probability that they choose their strategies on the axis. Well, this is pretty much the same sort of idea. So we've got our two firms. On our two firms, our firm 1 on the vertical axis, on the horizontal axis, and firm 2 on the vertical axis. Now, what are the strategies of these firms? It's the price. So, this here, along the horizontal axis, is the price charged by firm 1. This, on the vertical axis, is the price charged by firm 2. But remember, what firm 1 does, what strategy it chooses, is dependent upon what its rival does, what price firm 2 charges, and vice versa. So that's the basic idea. So, with that then, given that basic idea of what we're going to do, we've now got that line in the middle is a 45-degree line. And what the 45-degree line will do is it perfectly cuts that price space in half. So anywhere, absolutely anywhere on that 45-degree line, that solid line there, the price that firm 1 charges is exactly equal to the price that firm 2 charges. So anywhere on that line, both firms are charging exactly the same price. Now what I've done is put 2 crucial prices on that diagram. We've got PC, which is the lower price there, which is a price equal to the marginal cost of production. Now remember we said for both firms, the marginal cost of production was exactly the same. So there you go. There's PC. That's PC charged by firm 1, and on the 45-degree line, that's PC charged by firm 2. We've also, though, got a higher price, PM. And PM is the price that a monopolist would charge if it were supplying this market, such that it would maximise its profits. So that is the monopoly price level. That's the price that would maximise the profits in the market in its entirety. So that's a price of PM. So if either of these firms were supplying this market individually, i.e. they were a monopolist, what price would they charge? They would charge a price of PM. That's the profit maximising price that a monopolist would charge. So there you go. There's PM charged by firm 1, and there's PM charged by firm 2. So that's the basic framework that you've got in front of you. All I want to do now is derive and draw in the firm's best response lines. So what we're going to do is start off with firm 1. Now for firm 1, what does it do? It will want to charge a price such that it maximises profits. And bear in mind all of those considerations that we said before. Neither firm will wish to charge a price that's less than the marginal cost of production. Each firm will wish to capture the entire market. It would want to set a price that undercuts its rival. If it can do that, it captures all of the customers. So that very, very simple principle in mind, let's see how the best response lines would pan out. So, for firm 1, if we want to know the optimal strategy, the optimal price of firm 1, we ask ourselves, what is firm 2 doing? Well, if firm 2 was charging a price higher than PM, was greater than PM, what do you think firm 2 should do? Should it just undercut a little bit, whatever price it charges, and just charge a little bit less? Does that seem sensible? Yeah? It wants to charge, absolutely, it wants to charge a lower price. But does it want to just undercut it? If firm 1 charges a price that undercuts its rival, it captures the entire market. So it's supplying all customers in that market. Well, if you're supplying all customers in the market, what price would you wish to charge? What price will maximise your profits? It's not what your rival produces and just a little bit less. The price that you should charge to maximise your profits, if you're the sole firm supplying the industry, is the monopoly price PM. So, whenever firm 2 charges a price greater than PM, so we're looking at any point above that line PM. Okay. What will firm 1 wish to do? It will wish to charge a price exactly equal to PM. So that's firm 1 charging a price exactly equal to PM. So it doesn't matter if the price that firm 2 charges is all the way up there. It doesn't matter if it's down there. As long as it's greater than PM, and that's what it is above there. If firm 2 charges a price greater than PM, The optimal response of firm 1, the optimal strategy, the optimal price, is to charge a price exactly equal to PM. And so that's the first part of firm 1's best response line. That vertical line there at the price of PM. So, let's say firm 2 is reducing its price. As long as that price is in excess of PM, firm 1 will charge a price exactly equal to PM. What would happen if firm 2 charged a price exactly equal to PM? This is then our basic principle. If firm 2 charges the price of PM, what does firm 1 want to do? Would it also wish to charge a price of PM? The answer is no, because if firm 1 also charged a price of PM, what would it mean? It would mean it would only split the market. It'd get half the customers. Firm 1 knows, though, if it can just undercut its rival by a very, very small amount, it charges a cheaper price, and all the customers will come to it. And so that's what it will do. If firm 2 charges a price of PM, firm 1 will want to charge a price of just less. If it charged a price of PM, the best response line would have gone all the way down there to the 45-degree line. But it doesn't do that. It just undercuts it. Rather than charging a price of PM, firm 1 charges a price just less than PM. But that same principle will apply for any price that firm 2 charges less than PM, all the way down to PC. Or all the way down to just above, I should say, PC. Whatever price firm 2 is charging, firm 1 will want to charge just that little bit less. And so, that will then be the next part of firm 1's best response line. Where the difference, if they were charging exactly the same price, if firm 1 charged exactly the same price as its rival, that best response line would trace out that 45-degree line. That's where they'd both be charging the exact same price. But firm 1 doesn't want to do that. It wants to charge just that little bit less. So the distance, I'll just put it there so you can see it, that distance between the 45-degree line and the best response line, that's just a very, we'll call it epsilon, but that is just a very, very small price differential. So rather than charging a price of PM, firm 1 charges just less than PM. Rather than charging that price there, what it happens to be from firm 2, firm 1 charges just a little bit less. So you can see that. The best response line doesn't trace out the 45-degree line. In the diagram we've got, it's just shifted to the left. Just a small fraction less. And in doing so, it captures the entire market. And it's more profitable to charge a tiny bit less and capture the entire market, rather than charge exactly the same price, which is just a tiny bit more, and we have half the market. So you can see that then would be the optimal response from firm 1 to firm 2's strategy chosen. Well, let's take this all the way down now to get to that price of PC. If firm 2 charges the price of PC, what's the optimal response from firm 1? Should it just try and undercut its rival? Well, the answer is no, given what we said before. A firm would only want to charge a price if it's not less than the marginal cost of production. If firm 1 charges a price less than the marginal cost of production, it makes a loss. It doesn't want to do that. It's more profitable to make zero profits rather than make a loss. So, if firm 2 charges a price of PC, what will firm 1 wish to do? It won't undercut it. The best thing it can do is halve the market by charging the exact same price. But carry that on. What would happen if firm 2 charged a price even lower than PC? Would firm 1 wish to match this? It wouldn't. It's look, the absolute lowest price I can charge is PC. So it doesn't matter whether it's firm 2 charges a price of PC or indeed anywhere below PC. The optimal strategy for firm 1 is then to charge a minimum price of its marginal cost of production. And so that then traces out the best response line for firm 1. Given the strategy chosen by its rival, the optimal response of firm 1 is that red line there. And that's it. That's it for firm 1. All we now need to do, though, is repeat this analysis for firm 2. Now, the logic that lies behind it, the intuition and the reasoning is exactly the same. Now, obviously, the lines can look slightly different, but the principle is still exactly the same. What you need to remember, though, if we're looking now at firm 2, the rationale, the logic that we go through is given that firm 1 chooses a certain strategy, what's the optimal response from the other firm? That's what lies behind a best response line. So now we're going to do it for firm 2. So for firm 2, we would ask ourselves, what would happen if firm 1 charged a price anywhere in excess of PM? If firm 1 charges the price of anywhere in excess of PM, the optimal response of firm 1 is to undercut it and charge a price equal to PM. And so, that's what it does. I mean, it doesn't just undercut it. It doesn't matter how far in excess of PM firm 1 charges its price. The optimal response, the profit maximising response, is to charge a price exactly equal to PM. And so, remember, this is what we've got here. This is now, this is now firm 2 charging a price exactly equal to PM. And then the same thing before. Anywhere between firm 1 charging a price between PM and PC, optimal response of firm 2 is not to match that price, but just to undercut it. And so there you go. That's the next part of the best response line. Where again, that distance between the two, the 45-degree line and the best response line, is just that fractional reduction in the price. So rather than charging the price of PM, it charges the price, firm 2 charges the price just less than PM. Rather than matching its price, you charge a price ever so slightly less and capture the entire market. But it's that same principle. Both of these best response lines don't trace out the 45-degree line, but they just miss it, they just shadow it. And so, that takes us down all the way to that price of PC. And what would happen if firm 1 charged a price equal to PC? Would firm 1 wish to undercut it? No. Again, the same principles. The minimum price that firm 2 is going to charge is its marginal cost of production, which is equal to PC. And whenever firm 1 charges a price less than PC, firm 1 doesn't undercut it, it charges that same price of PC. And that is the best response line for firm 2. So red line, best response line for firm 1. Green line, best response line for firm 2. Now, so what have we got? Think about the way that we set these best response lines up. And when I first introduced you to them, we said that these would show the optimal strategy of either firm, given the strategy chosen by its rival. Okay? So independently, that's what they show. What would happen when these two best response lines intersect? That would give us a situation where both firms are choosing an optimal strategy given the strategy chosen by the rival. And what does that perfectly encapsulate? That perfectly encapsulates that point there where both of these best response lines intersect. That is the only combination of strategies where both firms are choosing an optimal response. And by extension, if both firms are choosing an optimal response, there is no incentive to deviate. There's no incentive to charge a higher price. There's no incentive to charge a lower price, given what their rival is doing. And what does that perfectly describe? That perfectly describes the idea of a Nash equilibrium. So if we look at that diagram there, that Bertrand model, we set it up in terms of best response lines, but there's only one point in that diagram where the best response lines intersect. Hence, there is only one Nash equilibrium. Now, these firms could choose any set of prices that they like, but there's only one that we're naturally led towards, only one plausible outcome. And that is the Nash equilibrium there, where both firms are doing what? Where both firms are charging exactly the same price, and that exact same price is just equal to the marginal cost of production. And so that is what we get. That's the outcome of this Bertrand game, where both firms are choosing the price to charge, played in a single shot, static environment. The outcome is that both firms charge a price equal to the marginal cost of production. But if you think about it, that's a little bit strange. We've set this up as this is we've got two firms competing against each other. There's only two firms competing against each other. An oligopolistic market. These firms will have some sort of market power. There are strategic considerations. And yet, what happens? Both firms charge a price equal to the marginal cost of production. Now, if I said this was a totally competitive market, a perfectly competitive market, where there is aggressive competition, a large number of firms competing against each other, we said, okay, perfect competition, all firms charge a price equal to the marginal cost of production. No firm has any market power, and any excess profits are driven all the way down to zero. That's perfect competition. That's with a very, very, very large number of firms. And yet we've talked about this model here, but there's only two firms competing against each other. And yet, the outcome that we get is still exactly the same. Regardless of the fact there are only two firms, each firm charges a price equal to the marginal cost of production. Exactly the same outcome as we'd get under perfect competition. And this in itself is rather strange. And for that reason, well, we've introduced this idea in previous lectures about paradoxical findings. We've talked about the chain store paradox. We've talked about the backwards induction paradox. Well, what we've got here is what is referred to as the Bertrand paradox. That even though these firms strategically compete against each other, strategically they choose the price. That's their strategy. But it's non-cooperative. Competing against each other. And yet, what happens? Even though there is obviously market power inherent to this market within these firms, the outcome that we get is exactly the same as we would get under perfect competition. We get the competitive outcome even though there are only two firms within the market. And this is a paradoxical finding. It's not what you would expect to find. You would expect to find a market with a limited number of firms. In some way, those firms are able to exploit their market power. If you go back to the Corno model that we set up last week, or the Stackelberg model that we set up last week, when we worked through and we formally identified the level of profits, well, if these firms were competitive, those level of profits would have been zero. So under Corno, profits were non-zero. So again, that's as we would expect. But here, under Bertrand competition, each firm charges a price equal to the marginal cost of production. Therefore, profits are zero. And that isn't what we'd expect to find. And that whole finding is referred to as the Bertrand paradox. So, let's think about that outcome intuitively then. And you'll see, when I come on to the exam paper, certainly from last year, certainly for this year as well, intuitive is a word that I drop an awful lot into exam papers. So, we've been through the mechanics of this. Why do we get this outcome? Intuitively, why do we get this outcome where both firms charge a price equal to the marginal cost of production? And if I ask you a question, intuitively, explain what's going on. Intuitive doesn't mean the reason we get this is because that just happens to be where the two lines intersect. That's not intuitive. So think about what's happening here. Why do the firms both charge a price equal to the marginal cost of production? And what I want you to think about is what we're looking at here. We're looking at game theory. We're looking at the optimal strategies of firms. And if we have a Nash equilibrium, neither of the firms will have an incentive to charge a different price. It will be happy with the price that it's charging. So, let's think about possibilities. would it be possible that either of these firms would wish to charge a price less than the marginal cost of production? Well, the way that we set up this Bertrand model, the way that we introduced it, we said that no firm would wish to charge a price less than the marginal cost of production, because if it does, it makes a loss. It can't cover its costs. And so it just won't do that. And so we absolutely know that the outcome of this game will not be with either firm charging a price less than the marginal cost of production. Because if any firm did charge a price less than the marginal cost of production, it would have an incentive to increase its price. Because by increasing its price, it would reduce its losses. So it will keep on doing that whenever the price is less than marginal cost. And hence, our Nash equilibrium cannot possibly lie with the firms charging a price less than the marginal cost of production. Because if it was, there would be an incentive to increase price. If you're changing price, it cannot be a Nash equilibrium. So that's the first part. Absolutely, the Nash equilibrium could not be with either firm setting a price less than the marginal cost of production. So, what does that mean? Well, we've now opened up the other possibilities. What about the other side? Let's not worry about price less than marginal cost. Why couldn't we have a Nash equilibrium where price was greater than the marginal cost of production? Well, again, this goes back to one of those bullet points that we put in that basic setup. That if any firm is charging a price greater than the marginal cost, the rival will always have an incentive to undercut it, to charge a lower price. So again, we could not possibly have a Nash equilibrium where both firms are charging the same price if that same price is greater than marginal cost. Because at least one of the firms would have an incentive to lower its price and undercut its rival, and in doing so, capture the entire market. So again, any price in excess of marginal cost, where the firms charge the same price, absolutely cannot be a Nash equilibrium, because there's an incentive to deviate. If there's an incentive to deviate, it isn't a Nash equilibrium outcome. So what we've done now is we've excluded all the possibilities, and the only other possibility is left is that when both firms are charging a price equal to the marginal cost of production. And now, what happens? Why is that a Nash equilibrium outcome? Well, would any firm wish to charge a lower price? Would any firm wish to undercut its rival? No. If you undercut your rival, you'll capture the entire market, but you'll make a loss. So the outcome is worse. So neither firm would have an incentive to charge a lower price. Would any firm have an incentive to increase its price? Well, if you increase your price, you then lose all of your customers. You'll be charging a price greater than your rival. And hence, that is the only outcome where price equals the marginal cost, where neither firm will have an incentive to deviate. And hence, that's the only Nash equilibrium outcome. It's an important part here. Don't worry about the formalities of it. The best response lines per se, all of the game theoretic principles I'm interested in. And that perfectly captured in the discussion that goes on there. That's intuitively why we get this Bertrand paradox, where the only plausible, logical outcome is for both firms to charge the same price equal to the marginal cost of production. So that's the Bertrand model, and the outcome that we get in Bertrand, known as the Bertrand paradox. Now, before we have our break for this morning, very, very quickly, I want to run through some ideas about how we might resolve this Bertrand paradox. So there are going to be 4 of them, and the first one, hopefully, should be fairly obvious to you. You've all done your assignments on Prisoner's Dilemma. Well, what would happen when we play and we know what the outcome of the Prisoner's Dilemma is? That we have a non-cooperative outcome. Our Nash equilibrium, where cooperation doesn't take place between the parties involved. But the whole point about the assignment, is it possible for long-term collusive behaviour to be sustained? Well, you know it's not possible in a finitely repeated game because of the backwards induction paradox. Hopefully you complete your assignments and that is not coming as new information to you. But what would happen if we repeat a game over a seemingly infinite horizon? Then it was possible to get cooperation in the prisoner's dilemma. Exactly the same here. When we played this Bertrand game, this static Bertrand game in a single shot setting, the outcome that we get, where firms compete against each other, means that all profits are driven down to zero. But if these firms play this game, this Bertrand game, repeatedly over a seemingly infinite horizon, that is, they don't ever know that they're playing the game for the last time, well then it's possible for collusion to be established, long-term collusion to be established. But just playing the game repeatedly over a seemingly infinite horizon in itself isn't the only thing that's required. We need appropriate long-term strategies. We need to think about the observability of outcomes. All of these considerations that you would have mentioned during your assignment, exactly the same principles apply here. Single shot game, there is no cooperation. We get the Bertrand paradox. But if it's played over a seemingly infinite horizon, with all of the appropriate, supportive and punitive long-term strategies, then there's the potential for the Bertrand paradox to be resolved. And in the long term, firms adopt strategies where they don't relentlessly exploit competition against each other. So that's the first one within which we could resolve this Bertrand paradox. Secondly, and I'll do this very quickly, is the idea of product differentiation. When I set this Bertrand up, I said these firms are producing exactly the same product. So, the only consideration that firms take into account is price. And they know if they undercut their rival, they'll capture the entire market. Conversely, firms know if they charge a higher price than their rival, they will lose all of their customers. However, if there's product differentiation, that last part isn't true. When firms are deciding what price to charge, they know that there's an opportunity to charge a higher price than their rival and not lose all of their customers. And so those best response lines that we constructed previously wouldn't be the same. The whole dynamic of what goes on there wouldn't be the same. So again, that would completely undermine the Bertrand paradox, that Bertrand model that we set. So that's more to do with, I'll put it in there, that is more to do with industrial economics. We're not going to go into that sort of route, but I threw it in there for you. The third aspect is differing costs. And certainly when Bertrand set this idea of the model up himself originally, that's one of the considerations that he put in there. Well, what would happen if these firms had differing marginal costs? Might not that change what's going on? And in particular, different marginal costs could easily arise due to proximity to markets. If one firm is more geographically distant from its market than the other firm, it will have higher production costs, it will have higher transport costs. And this will have an effect upon this Bertrand model. So, let's say, purely as a way to move this on, let's say that our two firm models, firm 1 and firm 2, that firm 1 has higher production costs. And let's say that these manifest themselves through production costs. It's more distant from its market. So its production costs are higher. And just to give you a bit of notation, let's say that for firm 1 then, its higher production costs will denote by PC prime. Now previously, we said that the marginal cost for both firms was constant, and that was equal to just PC. We're now going to say though, firm 2 again has this exact same marginal cost of PC, but firm 1's production costs, its marginal cost, is slightly higher at PC prime. So that's the way that we're going to set it up. How does that change the situation? Well, this is where you're going to make use of the second diagram on the handout. And what you'll see sketched out there is a diagram that looks like that. So, for all intents and purposes, this is the exact same diagram, but all I've now drawn in, rather than just PC and PM, as we did previously, we've now got that price PC prime. Remember, PC prime was a slightly higher marginal cost of production for firm 1. So, let's start off this time though by looking at firm 2 and its best response line. I won't explain it because it is exactly the same. All the incentives that firm 2 faces are the same as we saw previously. The best response line does not change. So it's that green line as traced out there. Firm 2 will never charge a price less than its marginal cost of production, and the highest price it would wish to charge when firm 1 charges a price in excess of PM in itself is PM. Anywhere between the two, it just undercuts its rival. So that's the same line as before. Now for firm 1 though. And the first part doesn't change. For firm 1, if its rival charges a price greater than PM, what does firm 1 want to do? Charge a price exactly equal to PM. So there you go. That's the first part of the best response line. And if firm 2 should charge a price equal to PM, what does firm 1 want to do? Just undercut it. And if it charges a price lower than PM, if firm 2 charges a price lower than PM, what does firm 1 want to do? Just undercut it. And that is what it will continue to do. But it will only continue to do this until, for firm 1, it reaches that price there of PC prime. That's its marginal cost of production. And now you ask yourself, would firm 1 ever wish to charge a price less than PC prime? No. If it charges a price less than PC prime, which is its higher marginal cost of production, it would make a loss. So firm 1 would never charge a price lower than PC prime. So there you go. Regardless of what firm 2 does, that's the minimum price that firm 1 will charge. If it ever charge anything less than that, it's making a loss. Could that ever be profitable? No. Would it have an incentive to increase price? Yes. So it can't be its best response line. So there you go. That is just the final part for firm 1. Its best response line. So now what have we got? We've got 2 best response lines. Individually, each one of them shows the optimal response of one firm given the strategy chosen by the other. Where do they cross? Again, in only one place. What does that mean? It means that there is a single Nash equilibrium outcome. And this one is where they both charge a price where, this one is where firm 1 charges a price of what? Firm 1, the red line, charges a price of just less. Firm 1, get that right please. Firm 1 charges a price of PC, there we go, that's firm 1's price. Firm 2 charges a price of just less than PC prime. So that's our Nash equilibrium outcome. In itself, what does that now suggest? These firms are charging different prices. Firm 2 is charging a marginally lower price. It's charging a price just less than PC prime. Would firm 1 ever wish to match that? No, it can't. If it does, it makes a loss. So now we've got one firm charging a lower price, one firm charging a higher price. So what does that mean? Well, it means that only one firm supplies the market. The way that we set this up, we said customers will buy from the cheapest producer. Who's the cheapest producer in this? The cheapest producer is firm 2, charging a price just less than PC prime. Firm 1 is charging a higher price of PC. And so all of the customers will go to firm 2. And they will buy the product from firm 2. Now why do I say though that this only provides a partial solution? Because we've got firm 2 supplying the market, and firm 2 is charging a price higher than its marginal cost of production. The marginal cost of production for firm 2 is PC. And what price is it charging? It's charging a price somewhat higher, up there. So, in that sense, it's a partial solution to the Bertrand paradox. We've got this non-cooperative behaviour, we've got these firms with monopoly power. But the price charge is greater than the marginal cost of production. But why have I described this as only a partial solution? Well, the problem rises, but now you've only got one firm supplying the market. And we've got one firm supplying the market. What would you expect that firm to do? You've got one firm in the market, surely you'd expect that firm to charge a price equal to the monopoly price. So, in that sense, we've got a partial solution to the Bertrand paradox, but it's not perfect. Because what keeps this market in check isn't actual competition from firm 1, but it's potential competition. So, that is what gives us a partial solution. Yes, we get prices in excess of marginal cost, but now we've only got one firm supplying the market. And that one firm doesn't charge a monopoly price. But a partial solution to the Bertrand paradox.